8 years ago, I had a 2-year-old in my arms. We lived in Cumming, Georgia, which was technically out in the middle of nowhere, but it was far enough away from Atlanta that you had a beautiful view of the stars. You could actually see them, even though Atlanta was very bright. And I'm walking in, and my daughter says, "That's beautiful." And she's 2, so she's kind of mouthing these words. And she said, "I want a piece of the moon. Can you get me some?" And so I'm like, sure. So I grab a piece and hand it to her, and she eats it. I don't know if she's storing it in her mouth or something. It's a moon rock. Anyway, so that really affected me because I really liked how she was, when I was feeling depressed, she would recognize it. Like code wouldn't work, or I'd be frustrated about a client not paying or something. And she would be like, "Don't be sad, be happy." And she'd be all cute and everything. And so that made me want to get her a piece of the moon. And so I thought about, at the time, Virgin Atlantic was doing interspace travel. And I thought maybe I could set up a college fund and a travel fund, so when she's 18, she'd go to the moon. But when I was 18, I'd be like, I want to go drunk to the moon. So I took away that idea. And then Elon Musk, said that you could do the same thing. So all these ideas about it. So I researched a way in which I could fly my own stuff, because I'm horrible at finance. I can't plan for college for my daughter. It's just not a skill I have. So I said, well, maybe I could use software, something I'm reasonably okay at, to send my own thing. And I found this guy who wrote a book around building CubeSats. It's basically a Rubik's Cube, and you can put an Arduino in it, and if you get a Kickstarter that may or may not happen, you can get a plasma drive, which basically just takes hydrogen, spits out water. Really, really low thrust, but the point of it is that in space, you ain't got much stuff against it, and so that thing can go really fast. So I was like, well, wait a minute, if you do the math right, you can put this much water in it, like those Tide balls, don't eat those, and it would actually go to the asteroid belt outside of Mars. And that would be cool if I could take a selfie of a meteorite. I don't think she would think that was as cool. She wanted the moon. I'm like, but what if you get those rocks that are just floating there? But anyway, that was kind of my gateway drug. And I didn't know that so much software was used in rockets in space. Maybe I'm naive, maybe it's my art degree, but I thought that rocketry and space travel is all hardware. And I'm not a hardware fan. I can write software, but if your hard drive breaks or you want me to install something, I don't know how to do that, and Googling doesn't help. So I learned so much about space travel, and it was very empowering to know that as a software developer, we could literally write code to send men to the moon. We can send satellites to other star systems. That was just absolutely amazing. And so I was so excited because I knew that they had the same problems we do, and a lot of the same frustrations with management we do, and some of the same problems with testing and things like that. So I got really excited to know that it's not those kind of people I put on a pedestal are just like us. It's very human. So that made me feel really good. So again, my name is Jesse Warden. I'm a software developer at Capital One. And today I wanted to talk to you about what I thought was the good and bad technical debt in space. Again, it's just to understand there's a lot of ideas that they created. But there's also a lot of ideas that we've adopted and modified from those times. And it was very validating to know where they came from and recognize that it wasn't just something somebody made up because they wanted to make consulting money. It was really to solve real problems for good and bad things. And again, build your self-esteem. So it's also a teensy piece of software history. So I didn't know. And these things I thought were really cool because I didn't know software was that old. So what I've done is I've cherry-picked 5 US missions and 1 European, 2 of which are successful and a lot of them failed. So I've done it in chronological order, so there's no point of saying, is this relevant to this particular technology? It's just I put it in order of time of when they happened. The caveat is these are my interpretations. I'm not a rocket scientist. I'm not very good at advanced math. So a lot of the things I've done dumbed down so I could understand it. So hopefully if I can understand it, y'all can totally understand it. The caveat is also these are I'm doing my best to give the respect and reference to them. I don't have context of what they dealt with. A lot of the Cold War paranoia. I was 6, too young to really understand. So technical debt, quick primer. I'm not going to spend the whole presentation on this, but it's something that's very dear to my heart is how do I write software that doesn't break? And if I send it on a satellite and I can't update it because I only get 1 kilobit modem speed to upload new software, how do I make sure it's right? And there's only 2 people I know who've done that well. And the first is game developers. Back in the 90s would have an army of QA people that would battle test this stuff. And those launching satellites. They figured out how to get software right enough that when they launched it, it would just work when it went to Mars. And so the idea of technical debt is just like my father who was trying to start a business. You need a way in which to borrow something to make progress. And a lot of the developers need to either learn a new technology, like I want to learn how to unit test React hooks, for example. And so when I explained it to management and product owners and Scrum Masters or a client when they were asking to build something, they would have no idea what that means. And so, especially with the banks, you would use debt, because that's something they understand. So use an analogy. And Ward Cunningham, he was the guy who actually invented it. So my dad, he had a boatlift business. He needs trucks, tools, barges, pile drivers. But he's literally the guy from Coffee is Only for Closers. He could sell anything, and I inherited none of that. I inherited his positivity in bad things, which is good, but I never inherited his sales abilities. So I was positive as my business was sinking. I wasn't getting sales. But anyway, he knew he could be profitable in 18 months, but he didn't have 400,000 cash running around because we both inherited the inability to manage money. And so the goal is, if he could borrow that from a bank, he knew he could totally pay off the loan. He said 1 year, I took that as 3 years, but that's cool. Without financial institutions that a society can trust, debt allows us to move forward. Otherwise, you just have stagnation. And so you don't hear that from Silicon Valley because a lot of those people don't have that invested interest. Whereas if this is your loan, this is your money. It's just like the Sun Tzu Art of War. If you want to win a battle, you make sure you put where there's no escape. So if you're going to lose your house and your mortgage and your family, even with an LLC, like this is good motivation to succeed. So technical debt, same thing. I'm a functional programmer and I want to leverage suspense for lots of data in React, for example. I've never unit tested React hooks. You have people arguing about it right now on Twitter about what's the best way. And I don't know if like Dan Abramov started smoking pot or something, but he seems like really blasé about the whole thing. He's like, well, you know, it's like a side effect, but like you could do an integration. It's cool, bro. And I'm like, what? Dan, we need guidance. He's like, yeah, but it's only like a recommendation. We haven't really finished it yet. I'm like, it's too late. Once you say that on Twitter, all the React devs are like, right? Which is good. It's not negative. It's just insecurity, right? And so the way you fix that as a coder is you go test. You go learn. So I want to do it on a real project. I'm going to have either a ton of folders in my documents folder that are just playing around, or I'm using a real project with real deadlines with real people that need this software in order to do it. And the only way to do that good technical debt is writing refactor, for example. It's the rebranding of test-driven development because TDD got such a bad knock. And so that's the good technical debt. The bad technical debt would be like, anyone know what regular refactor? You ever heard that? It's a huge .NET thing. All right, one. All right, so it used to be called TDD. Kent Beck wrote a book. It's a really good book, actually, about dealing with legacy code. And if you ever worked with code that isn't yours or is 12 years old, it's a wonderful book. It tells you how to test it and how to deal things that are sometimes untestable. And what Kent Beck wrote was that you write a unit test that fails, you write the minimum amount of code to make it pass, and then you refactor it a little bit. The problem with that was he's talking about lines of code. And what happened in the .NET community, even with strong typing, is that they would have 3,000 tests for every 1,000 lines of code. And so as soon as they had to refactor a feature slightly, all these tests would break. They haven't seen them in 6 months. And they'd be like, I don't even know what this test does, dog. I'm done. Because like there's gallons of mocks, whatever. And so this is the opposite. This is test your feature, test your public interface. Don't worry about the privates. And that's an ideal situation, but it doesn't really work. So the point of this is the refactor step. And the reason it's called refactor is that you have tests to tell you if what you did broke or not. There's a comment made by a couple people saying if you are changing code without test, you're basically changing stuff. And so bad debt, if you don't pay off the debt for a while, like my father, at some point you're paying nothing but interest, and you're not actually paying off the debt, and it's affecting profits and everything else. Same thing with bad technical debt example. There's so many varieties of this could happen. No unit tests, no automated deployments. You're violating do not repeat yourself because you're in a hurry. You got a deadline, right? You could work for an agency. Maybe you never pay off your technical debt. And so those are the kind of signs. No love is a huge one. Sometimes you're put on a project, or developers are put on a project, where they either just there from 9 to 5, or they just don't love the code base. They don't give it love, and they don't care for it like it's their own. Or maybe they're not empowered to do so. Maybe they have to share it with some third-party vendor. And so a lot of that technical debt is never paid off, and it just becomes miserable to work with the code base. And so I was more concerned about the bugs. That was what I was worried about. How do I make sure there's little bugs as possible, little errors as possible? And yeah, most importantly, I mean, paying down technical debt is not fun. Writing a unit test, making the code work, that's exhilarating, right? But working on massive technical debt, like that's not fun. And if you like what you do, you never work a day in your life, so I want to guarantee I enjoy my job instead of hate it. All right, so let's talk about Mariner 1. Mariner 1 was in 1962. The software for the rocket, I think it was like in this really whack assembly. it was going to be the first planetary flyby of Venus. And so a lot of the efforts in sending these satellites was to go to Venus and measure all kinds of science things, almost the exact same thing they do today. This is back in '62. It was supposed to be the first planetary mission. Mankind sends a thing to another planet. Not the moon, but a planet. That's bonkers and awesome. It was also the first interplanetary probe. When you hear the word interplanetary probe, you think of like Star Trek or something, but this was something we built. And we built 2 of them to go together, right? It was also the first one to orbit a planet. We'd built things that orbited the planet, but we'd never built something to go to another planet and then get in its gravity and slow down and hang out and take pictures and whatnot. It was also the first gravity assist. Gravity assist is what they did in that even Star Trek or odd Star Trek, where they went around the sun to go backwards in time to get the whales. Like I said, yet another weed person. But the point of it is that the scientists are like, yo, if you just fly it near this planet, it'll like make you go faster. And the coders are like, all right, how do we test this? And it's like, well, you have to put it in space. Oh, okay, so test and prod. Got it. And so that kind of thing is bonkers, right? So it was an amazing mission, but it blew up 5 minutes after launch. It was like $18.5 million of that plus the cargo just gone. And so remember that number for a minute. So 18.5 million. Real quick, every single rocket is supposed to have something called range safety officer. Basically what that means is the area of which the rocket can go, you can guarantee it's safe. And what that means is if you're building model rockets, it has a parachute. So if that big metal thing doesn't fall on somebody's head, right? If they're gigantic rockets, you basically have explosives on it. And you don't need a lot, because once it hits the rocket fuel, it blows up. And so the goal is that if your job is to say, all right, tell me when the rocket's out of control, and then they blow it up. And that could be if people are on it too. And so that person has a significant responsibility of the needs of the many outweigh the needs of the few, which is not a job I'd ever want. And so the points that I found fascinating is no clue what the heck went wrong. It blew up and they go, what went wrong, engineer? Oh, I don't know. You work at MIT. Oh no, we blew it up. It's like, oh my God. And so we are paying these people out of our taxes to learn about rockets so we can nuke the Russians back so they don't nuke us first and take over the world. I'm paying taxes to save my life, my family's life, and guarantee I have grandkids. And they're like, cool, but I don't know what went wrong. It's like, oh my God. And so Congress was like totally frustrated. So the engineers, this is like very similar to the software I deal with at work. Like we have monitoring stuff, but like sometimes it breaks, I don't know what went wrong. And this is why App Dynamics and all these other things invest in Datadog, use these plethora of suites to know what's going wrong with your software. Or if something does go wrong, you actually have an idea instead of a fire drill. Like, it's not proj down, what do we do? And so the engineers and officials, they dumb down explanations because an executive, not a manager who's tech savvy, but an executive would go, what happened? It's like, we were missing an over bar in the pi symbol. I'm sorry. Like, what do I tell Congress? We missed a hyphen and the math was wrong and the rocket crashed. And you're like, oh, okay, cool. And so that caused this confusion about what really happened. We still don't know exactly what happened. And they contradict each other. The engineers say they were missing a hyphen, but then they wrote a letter to Congress saying that they were missing an overbar, and the rocket crashed, but the rocket didn't crash. They blew it up. Like, they did it on purpose. The rocket didn't crash anywhere. Like, they exploded in the sky. And they also, this is what I used to experience in an agency. Like, if you had bugs or a client got ticked off, you never dealt with it because it was due Friday. So, like, just make it work. See, you never did damage control. You never figured out why do they have a bug when they type in the form and the page just locks up. I don't know, just finish it. Okay. And so that is exactly what they did. They said, look, Mariner 2 launches in 5 weeks. I don't care. I'll go talk to the press and make up some BS. You guys keep working. Okay, yes, sir, right away, sir. I'll launch the rocket. And so the good news, Mariner 2 did go. It measured all kinds of cool things about the solar wind of the sun. And they were trying to figure out if when you sail from, like, Britain to America, you follow the currents, right? You go high up this way, and then you go down this way on the way back. They were trying to think if you could sail in space from all the photons and particles that are blasted away from the sun. They're like waves. They're like water, but they're in 3 dimensions. How can we surf that? And so this is what it measured it. So Mariner 2 was successful. It was an exact duplicate of the actual satellite, which is good news. So even though the rocket destroyed the first one, they had an exact copy, quote unquote, to the right. So the software on that one worked. It's just the rocket software didn't work. Anybody seen Hidden Figures? Yeah, wonderful, wonderful movie. So it wasn't this wonderful woman in particular, but a lot of developers like me, I don't know math. Like, I went in geometry, I'm like, I don't know, this is lame. And I almost didn't graduate high school. It was just, I was reading D&D books or something. Don't get any ideas. And so what happened is a lot of these mathematicians would come and do all the calculations, and I'd be like, the derivative of the smooth velocity. Yeah, I don't know what you're saying, but cool, I'll just make a variable called velocity. Got it. And so these women, a lot of women, would give us these mathematical algorithms, and they'd plug it in, and that's how they would do it. So there was no idea of these mathematicians of what unit tests were, of what property tests were. And so I would just say, like, well, she's smart. She says the math works on paper. It must work in code, right? Wrong. That's why the 18.5 million blew up. And so if you want to see what there's theories of exactly what happened. I think the overbar makes sense because it's very mathy. As an engineer, I wouldn't say hyphen. Like, you don't use hyphens, even in assembly. So it's the overbar is basically on the top. So what that means is, and I tried to explain this to Jay on Facebook, but I completely failed. Basically, if the rocket is going super fast and shaking in the wind, right, it's okay if its velocity goes slower or faster. That's okay. But you have to know where you are. And so they have this antenna on top of the rocket, and they have an antenna on the ground, and they say, yo, because this is before GPS. And so the rocket has to know, like, am I not going to crash in the White House? No, dog, you're fine. Keep going up. Okay. And so they would tell the rocket. The problem is the antenna was crap. It was total crap. Plus, it was crap on a rocket that was shaking like this with massive excision dubstep. And so it had no way to actually talk to the ground. And so the software's like, okay, I'm in Fortnite, and I'm shooting this guy. Is he there? And, like, you have a ping of 1,000. Right? Like, did I or did I not shoot him? That's exactly what was happening in the software. It had no idea where it was. And there was also a theory that they used a comma instead of a dot in Fortran, and that caused the for loop to go bonkers. But I think it was really just the algorithm messed it up. So they could have fixed it with unit tests. They could have just said, all right, so what do I put in this derivative? And the hidden figures could have said, oh, yeah, just put like 2. And then put 2 with a float of like 50 decimals, right? That's all they could have done. And they could have detected very quickly that running it 3 times in a row would have failed. Which is funny, I just asked you politely the other day, don't make multiple assertions in tests. This proves I was wrong, sorry about that. So yeah, property tests or fuzz tests, instead of writing like 50 unit tests of possible possibilities, property tests basically say you can generate your test data, and it does a random seed, so you get 100 unit tests generated for you every time with random data. And they find these kind of weird problems with, like, if I send it an empty string, a -1, a null, and undefined, you let it do it instead of you writing it yourself. And they're a little bit slower, but they would have found this kind of problem. So if you're curious more about, it comes from QuickCheck, which is a Haskell thing. John Hughes of Haskell fame. This YouTube video, he talks about don't write unit tests, generate them for Haskell, but there's a JS Verify version for JavaScript. So Saturn V is actually a success. This is a rocket that we were trying to develop. So the military's like, all right, the Russians are gonna nuke us. What do? We gotta build awesome rockets. And then the scientists are like, we gotta make a mission of peace and, like, bring the world together. I know, let's put people on the moon and televise it. And right, so these two people are working together, which massively like compared 2 different types of people. But Saturn V was amazing. It started from a horrible thing, and that was the end of World War II. The Russians and the Americans started getting all the either Germans or ex-Nazis who knew anything about rocketry, and they wanted to bring them over because the Russians, within one night, managed to get, or at least request, asylum of 2,200 of these rocket scientists to come to Russia to help them build rockets to nuke America and everybody else who likes us, which is totally lame. We got about 1,600, so we were kind of late to the game. Even during the end of the war, there was other operations to get it. But the goal really was this guy. I don't mention his name. You can see it on Wikipedia. But the V2 is what they blasted at Britain and Belgium and killed, thousands and thousands of people. Thousands more died in actually making it in concentration camps. So we were using the smarts of these people for something that was on this side of the fence. Getting people to the moon for world peace is amazing. For the military machine, it was kind of disappointing. We had just ended a war, and now we're creating a Cold War from it. So think about more unit tests. We talk about unit tests. The Germans wanted to. Anybody know how to make a German irritated? You find a flaw in their logic. It drives them nuts because they're like. Anybody ever seen the movie Helvetica? Designers might know it. so he talks about designing the font and how it has to have all these rules. Like that's the quintessential version of logic and design. And so they were very naturally about building rocket pieces in isolation, testing them together, putting them together. Very functional programming minded, right? Composing functions. In this case, they're testing. The problem with that is it takes forever. And as soon as you have 1,000 unit tests and want to deviate your design, you have to redo all this. And that's logical, but we didn't have time. We wanted to beat the Russians, man. We were super scared. And so George Muller, who was director of NASA at the time, basically said the first idea or popularized of all-up testing. And it's basically like you don't want to do integration tests in space. You don't want to do end-to-end tests in space. You actually want to put the software on the rocket on top of the module with the lunar module running its stuff with the antennas, talking to ground control to make sure everything works. You don't have to launch it, just test it out. And the Germans are like, that's ridiculous. Like, we have to build the stuff and it might not halfway work. He's like, I don't care. Like, those kind of problems of integrating, right, what we saw with the Mariner 1 rocket explosion where the antenna didn't talk to the ground control, those kind of things were super integral. So if you're a full stack developer and you're doing not just greenfield development, this is a very, very amazing concept. So your front end, we inherited a project that it doesn't work in IE. So we didn't know that until somebody actually put it in they went to in production and in our QA servers and see it. So just a minor thing. We were fine with developing in Chrome and Electron locally, and it was all good, right? So even from a front-end perspective, you got to integrate with the world as quick as possible. You don't have to fix IE. No one prioritizes fixing IE, unless they're like 90% of your customers. But the point is that you know that now, and you just put it in your backlog or whatever it is you organize things. Your front-end API, JSON API. This happens all the time. It's like we serve an API. Cool. I got HTML500 error from IIS. Yeah, no one runs Windows at this company. Okay, what is this? What is this? You told me you give me JSON. Well, I give you JSON sometimes. Like, you wouldn't know that until you had spent the days, look, I'm just going to get one route and Restify or Express are happy. I'm going to get it in QA and see what happens, right? API code's legit, but the database either doesn't scale, doesn't work, the IAM policies don't work, blah, blah, blah. Orchestration API, this is the worst. You have now multiple points of failure. And what do you do if only one of your 4 services work? You got to find that out early. Sometimes you won't know about those questions until you actually implement it. And then database, I don't know. Databases are depressing. So anyway, that's the point. Is like, I'm not qualified to talk about them anyway. I'll just make up some BS. So Saturn V, basically, because of George Muller's desire to integrate tests sooner than later, and then to piss off the Germans, they're like, all right, fine, we'll unit test afterwards, fine. They got to the 3rd flight of this rocket versus the 10th and saved millions of dollars years ago. And it was one of the many factors, not the only one, but one of the many factors that we, quote unquote, beat the space race against the Soviets. So Apollo was one of 3 missions to get men on the moon and bring them back safely. It was a big, big thing of Kennedy's presidency, even though he didn't really know the technical details. Sound familiar? That thing on the bottom right, Sputnik, you don't say vodka, you say vodka. So Sputnik, that thing scared the living crap out of Americans. I cannot effectively articulate how frightening this was, that the Russians were able to launch a missile in space, deliver a thing that could not only look at us, but drop nukes and annihilate us, and there was nothing we could do in retaliation other than send armies, and they would get nuked too. And so that was really frustrating for Americans. If anybody's seen Patton, the old Patton movie? Really? Okay. So I love that movie, not because of the movie, because of the beginning speech. So you can actually watch the first part of the movie, the speech, and turn off the rest. He talked about, and this is propaganda, but the reason we're going to win the war is that Americans love a winner. They hate, the thought of hate is, the thought of losing, is hateful to Americans. And so that idea that we were just getting annihilated before we even played the game was, you could see people being interviewed on the news who were like about to punch the reporter because they were so bad. And so this set of 3 missions of Sputnik was launched. Mercury was to basically they had 3 missions, Mercury, Gemini, and Apollo. Mercury was to put a man in space, return him back safely, and learn a bunch of stuff about launching rockets, launching men into space. They did it with animals and stuff like that. Gemini was to put 2 of them in space, and then safely return them and learn about space maneuvers. Can we dock? Can we detach things? Does the math work as we're rotating around the planet, rotating the things and attaching them? Does all that work and we don't kill anybody and we can bring them safely and do it well? And then Apollo's put 3 men into space, land them on the moon, and return them safely. And so the idea of Apollo was one person would stay in the command module, the lunar would detach with 2 guys, they'd land it, come back, reattach, and that was insane. And so the thing that I loved about this mission was the Apollo guidance computer. NASA had no clue what a software developer was, what the requirements were. They said, we just need software to get them into the moon. IBM's cool. You know, the saying back then was you never got fired as a manager for hiring Big Blue. They hired MIT, and they said, here's the contract. And the MIT looked at it as like, so what do you want us to build? A computer to get them into the moon. Okay, what about the requirements? We have no idea what that means. Right? This is before software requirements was thing. And so it was written in assembly code. It used core rote memory called lob memory because it was literally weaved by little ladies. It's not a joke. And so if you wrote bad code, it was weaved into it and you were screwed. And so it's like, yo, grandma, can I write a new program? Can I recompile? She'd be like, nope. So this was, but it's awesome, but it's scary, you know, right? So I'm going to run out of time if I talk about this woman. I'll talk about her all day. So she devoted her career to preventing errors. And I have struggled for the past 5 years to find ways to write code with no errors. And it seems impossible, but I'm going to keep trying anyway. So anyway, she eventually started to lead the AGC program. She started out building some kind of like weather or missile thing for the military. And every time there's an error, it would beeps and it would be like some rave would happen. And everyone would like, your code didn't work, haha. And so she learned very quickly as a young age not to like let errors happen. That was a thing. And so she jokingly called it software engineering, but it wasn't really a joke. It was more to, she recognized what they were doing with code could kill people and ruin the moon for the rest of humanity's life if her code didn't work. It was one of the first, not one of the first, but one of the most prominent things where it was fly-by-wire. You literally press buttons to fly the ship. You didn't have these test pilots to actually fly the spaceships. And so she kind of is known for inventing software engineering. And I've seen people on Twitter say, well, we're not really engineers. And I just gets me so pumped because I'm like, dude, that's so wrong. But anyway, her career starting a couple companies to prevent errors. So she would go in the computer and she would have to test her code in like real life environments. She'd have to sit there and press her buttons like, you know, code works, but this is super uncomfortable. Maybe if I made 2 switches. And so she was doing like integration testing, indent testing with her stuff there. And because, you know, the same problems back then, childcare, right? And companies not paying for it, she had the same problem. So she would bring her daughter to work and her daughter would see her play astronaut. And what do kids do? They emulate their parents, and it's not always the good things. And so, in this case, it was a good thing. So she emulated her mom, pressed the button, and it crashed the computer. Right? She hit the pre-launch button. Right? So if you initialize variables, you set your trajectory in an array, and you track where you're going. And you hit the pre-launch, it goes, okay, I need you to reset the array and reset where we are. And the computer's like, what? And it threw an exception and blew up. And so she was freaking out because she knew the men of Apollo were going to go to the moon. They'd never gone this long before. They'd never existed this long in space before. And she was worried that they would basically crash the computer and be stuck around the moon and not know how to get back. And so she tried to fix it. NASA said, quote, test pilots are highly trained. They won't press the wrong button. And it's, you know, so like, my wife isn't here, so I'll say it. What do women do when they're dealing with dumbass men, right? They compromise, like, fine, you're stupid, whatever, I'll capitulate. So she put a label and said, do not press this button when you are in space, dumbass. That's what she wrote, and they couldn't fix the software, but they could put a label or near a switch. It's ridiculous. So the men were so tired because this machine was beeps, and these guys are like, you know, I'm macho World War II, yeah. And like they wouldn't shut up, and they're talking to Houston 24/7 because it's so cool to be in space, talk to Houston. And so one of these, the guy in the back was up for 36 hours. I'm not going to tell the disgusting story of what happened when he took a sleeping pill, but go read it. You'll understand why they didn't sleep. And so at 36 hours, your brain doesn't work. Like the Germans were one of the first to use sleep deprivation as torture. And so it was clearly working. So what did they do? They're like, I'm so tired, I'm just going to pre-launch. Like, what are you doing? We're at the moon, you moron. And so anyway, she was concerned about how to fix it. And so she learned from that, and her team learned from that. And that's where they created the concept of supervisor processes. So if anybody in here has heard of Erlang or Elixir, where they would build the phone systems around it, they weren't concerned about software failures. They were concerned about hardware failures. They would literally have this computer tower. I don't know if you guys remember those. They're basically a really big Mac Minis. But actually, you know, some of the millennials probably don't know what a Mac Mini is. Anyway, the tower was like attached to a tree. And this is a fact. If you go look at some of the most horrible things that ever happen to computers, it's squirrels. It's unbelievable how many squirrels just say, oh, computer, attack. It's like, what are you doing? And so the ability to make sure phones are up, because if you're calling like an ambulance or something, or the military's calling, you need to be ensured that those are working. And so Erlang was designed to never go down, and so it would have supervisor processes that would work in a concurrent way. So she and her team kind of started that idea of creating concurrency and parallel processing, but more importantly, supervisor processes. So if the program crashed, it's okay, reboot it. And back then, rebooting was like in seconds. So the computer crashed, you would see the beeps, and like, I crashed, and you'd like restart really quickly. A lot of that technology is in Abrams tanks, for example. When they fire, it's so powerful, the computer reboots, but it's super fast. So in Apollo, she had that software in there, and right before when they detached the lunar module, that thing on the right side, that actually detaches, and that's what they land on the moon, that thing started doing beeps, and they were freaking out. And yeah, I'm not going to get to Ariane. That's all right. So Apollo, right before they saw these beeping errors because they accidentally turned on the rendezvous radar. And basically what that computer was saying, look, we are not going to be able to do real time. I know you need to land on the moon, so I can't really tell you where you are. But if you want to land, I promise I won't kill you. And that's what the computer was saying. Houston knew, like, all right, it's a bogus error. What that means is most concurrent systems like Go and Elixir and Node with PM2, where you have multiple processes, there's no priority, right? Everyone's like equal. Where they built priority, they said, okay, if you land on the moon, number one. If you want to know where you are related to the other thing, two, right? So the computer was smart enough to prioritize that concurrency, those promises, for example, in JavaScript that are running, it could prioritize it. And so that way, when they were landing, they could just ignore the error. And Houston knew what that error was. They actually, remember when we put error codes? This is where, oh yeah, P1, don't worry about that. Like that error code really had a lot of value to make sure that they could actually land on the moon. When they got, I don't know, 30 seconds to a minute next to it, there was a bunch of additional errors because they were running super low on fuel. Buzz Aldrin got so ticked off, he just grabbed the stick. She had built parallel computing to work what they called like man in the middle. Basically, you could do a joystick and the code at the same time, so you press the button, it would still fly, but you could also fly manually. All because she knew how to do priority scheduling, and it's like, oh, he's controlling it, it's all good, right? So amazing, amazing, amazing stuff. I told you I talked too much about her. So anyway, I don't want to talk about that anymore. So the lessons are insanely good air handling. She's devoted her career to doing this. This is one of the first things that things like Akka, Erlang, and a lot of those other ones are spawned from Go, for example. If you never look at, if you're a Java dev or a Scala dev, definitely check out Akka. It's basically small little processes that supervise your stuff. If you're Node, you already know this is PM2 forever, right, for actual Node processes. And web workers in the browser. Somebody's got to manage those, and if they crash, you just spawn a new one. It's not a big deal. So the Space Shuttle Challenger, I'm not going to talk too much about this because it was super depressing. On its 10th mission, so the shuttle, the white one, the shuttle, it's flown 9 missions, done a lot of amazing, amazing science, launched a lot of satellites. On its 10th mission, it was supposed to be the first teacher in space. So of course, every school in America had it live on TV. CNN was this is one of CNN's first live broadcasts. And I was 6 at the time, I think. And it was also supposed to, I did a lot of other science, but the cool thing was going to view Halley's Comet from space for 6 days. So we'd get some amazing pictures of that awesome comet. So 73 seconds in the flight, it literally broke apart, killing all 7 crew members aboard. And a lot of kids, myself, saw it live on TV. We saw a snuff movie when we were kids. It was over and over and over. So that was super impactful about not wanting to do errors. So I managed to get my hands on a guy who worked on all these shuttle programs. And I asked him, I said, what happened after Challenger? Did management make a lot of cruff, but nothing ever changed? And he said, we used to be able to release code in 2 weeks. After Challenger, and even though the program was frozen, we couldn't release code for 18 months. So like after 18 months, is your code even still relevant? I thought that was horrible. It seems like it's going backwards, not forwards from that. So anybody know these 2 guys? One on the left's not his real picture, it's his icon. One, all right, cool. So this is a guy who helped build Stack Overflow. It's where most of us, well, I don't know about y'all, but I copy paste all my code from. The guy on the right is super liberal, and I love him. He talks about culture and not doing the crunch and working 30 hours a week and allowing people to have kids and lives. He doesn't like TDD, and he likes Ruby. But beyond that, he's cool. So these 2 guys measure the health of a software company and how quickly you can change one letter and push it to prod. And so that should look disgusting. You're already at 2 weeks, which is bad, and now you're at 18 months. So that's really bad. So one thing he told me was interesting, they had 1,000 unit tests for every line of code. What? I'm not maintaining that. You know, if your code doesn't work, you can kill people. All right, dude, we need to talk about this 1,000 unit tests and death. Like, I don't know about that. My favorite was the code reviews. They'd have to detect when the rocket secondary burn would come on. If lightning struck, the code wouldn't know to turn the rocket off, so they had to do code reviews to move the line in case lightning struck the rocket. First off, who's launching rockets in a thunderstorm? But whatever. So cover all systems. And it would constantly run out of system resources because there's so many unit tests. These kind of problems, thankfully, are still here. Which sucked. So anyway, what was neat was they would, back then they had tape drives, but they would have epic fixture data. These spaceships would go around the moon, track everything that happened in the OS, and record everything in like Splunk or Elk or whatever they called it back then. You would take this data and shove it into your new software. So you're like, well, we need, you know, all our fixtures and test data is fake. Bro, this is from like 9th mission. This is real stuff. Like, let's see if our software works. Oh my God, it's probably gonna work on 10th. So I thought that was really, really neat to actually record stuff and use on the new stuff. But this is the first time in one of these that we had a management problem. And I've got no time left. But I didn't like this bottom one. Prove it isn't safe. And a lot of times we have to, as developers, prove there's value in testing, prove there's value in best practices, prove as designers that what's best for the user trumps what the business says. And so I like this a lot because this is where NASA, once a very lauded software place, starts to get really familiar. So Richard Feynman, if you don't know, he's a very famous physicist. He has a great analogy on how the sun works with wood burning. It's amazing how he, as a complex subject of carbon, he basically talks about when a tree grows, it's absorbing sunlight. When you burn it, the sunshine comes out. Like, very poetic guy. So he was dying of cancer, and they begged this guy to tell him what went wrong with Challenger. So he's literally dying of cancer. He's like, all right, heck with it. So he says, as long as I can talk to the public, and as long as I can tell exactly what went wrong in the paper and you include it, I'm willing to participate to help figure out what actually happened. And I like this a lot because a lot of business people, especially when I work for agencies who just didn't really care, they were like deadline-driven development. This is great. He's like, look, you can write crap code, but eventually you're going to pay for it. And I don't want managers to suffer, but there is a small part of me that goes, I told you so. And so I like this quote. It was, unfortunately, if he could turn it to software, it'd be even better. This thing is awful. So Mars Climate Orbiter is amazing because we ran out of money. No one wants to do space anymore. And so we started sending tons and tons of robots to Mars instead of people. But the Mars Climate Orbiter was so badly managed. It was supposed to act as a communication relay. So let me show you this, for example. Where's the picture? There are, like, this is so out of date. There are so many rovers and landers. Landers land, rovers land, and then go places. So there are so many of these on Mars, and it's very hard for them to talk. It can take anywhere from like 45 minutes to 2.5 hours based on how far Mars is behind the sun with the Earth, with the satellite over there, to 45 minutes if they're on a line. And so having something orbiting as a relay for those communications would increase our ability to communicate to them, reduce lag, right? No lag kills on Fortnite. And more importantly, we could actually use it to do additional science around the atmosphere of Mars, which, you know, can we terraform, for example? Unfortunately, NASA used, like, I think the Imperial system, and Lockheed used metric or whatever. Anyway, 125 million, poof, all because of that communication error. But it wasn't that simple. There was a lot of mismanagement errors. The first, two of the devs are like, yo, dog, there's a bug. And management's like, dude, it's fine. Like, it's been going to Mars. It's mostly on track. Don't worry about it. We've had to compensate every time we, readjust. They even had a meeting to fix it, but didn't end up doing it because management's like, you need to prove to me why we need to re-upload software to satellite. Like, they can upload software to a satellite, and management's like, nah, dog, it's fine. The Mars Global Surveyor actually had code in there that they could copy pasta because it worked. It converted newtons to pounds, and it was so bad. And I think it wasn't common enough. I think as long as it's common, you can be like, all right, just put that here. Okay, initialize it first, got it. And you can make it work. It was so bad, they didn't even know how to include it in conversion. So they had a solution, but they couldn't read it. And so what they think happened was that it actually went to 57 kilometers instead of 226, got way too close to Mars' atmosphere, went way too fast, and basically exploded once the fuel tanks got hot. That's what they think happened. And they had like about 3 weeks to fix it. So depressing. So again, the attitude of management was prove something was wrong versus prove it's all right. If you're building these, $125 million satellites, is it okay for every unit test? No. Like, where's the logic in that? These quotes are brutal. I'm not going to read them all, but basically these developers are just tearing apart this company. How we done in test wouldn't have happened. They use 30-year-old code base. Nobody knows how to use it, blah, blah, blah. So anyway, leadership invested in technology practices. Every company I've been to, no matter how bright the engineers, unless leadership gives a crap about empowering you to succeed, none of this matters. Modern languages, who wants to code in Fortran? Not me. Unit test and indent test would have helped a lot to verify this. They actually had code to prove it. And code comments, this is the first time code comments could have saved $125 million. People say, you don't need code comments if it's self code. Well, this code isn't, but could save a satellite. Perhaps you could comment it. Ariane 5, first European rocket. Most of the Ariane 4 and stuff had a wonderful track record, but Ariane 5 on its first maiden voyage, it went cray and exploded over the Atlantic. So they basically saw it was going all crazy and they blew it up. It was supposed to launch Cluster 1 to study Earth's magnetosphere. So when we have northern lights and you protect ourselves from the sun, how does it work? And it exploded 40 seconds after liftoff. Basically, decades of work, $7 billion to build it. That plus the satellite, $500 million, gone. You're going to love how it worked. So they had to convert a 16-bit to a 64-bit to 16-bit integer. But the Ariane 5 engine was so much more powerful that when they did it, it was way higher than 32 because the engine was so strong. It was like a couple million or something. They tried to do it. So they threw an exception. The worst part about the lack of try-catcher on this particular method, three other conversions of the power had try-catch, except for this one. They're like, no, it worked in Ariane 4. So they copy and pasted it over. What in the... So, lesson from this, proper air handling. Try-catch is not a bad thing. What about performance? Okay, you know what? You and your performance go debug when it breaks the prod. I'm going to go drink it. Manual Nuremberg code. So Elm does this. I don't do enough finance or numbers to know why, but Elm actually manually makes you convert it with compiler help. Property tests would have found that if you'd thrown bogus numbers that were like, this isn't going to work with a large number, right? And so if you're curious about a lot of managing technical debt and all these space missions, this guy is great because he talks about where TDD went wrong. He doesn't say like, TDD is awesome, you should do it, and test first, and blah, blah. He's like, look, here's all the things people do wrong, here's what's right, here's how to do it right. There's a guy, Hillel Wayne, he's very smart, so he says some strange things, but if you follow him on Twitter, he can teach you a lot about formal methods. It's the only scientific way, continually proven, to write bug-free software. I don't know of anybody who does it. And that YouTube video, the link there. So Mariner 1, if we had used unit tests with his algorithms, they would have worked especially, rather than the rocket saying, well, we didn't do the math right. And property tests can give it whack data. You don't have to do that. You don't have to write 100 unit tests. Property tests will do it for you. Saturn 5, get everything together. If you're a front-end developer, integrate it as quickly as possible. Apollo 8 was, again, concurrency with priorities is cool, but there's now tools like TLA Plus that allow you to mathematically determine if this user logs in with this credit card, but this process goes down, and the value is not actually set to the database, what happens in that scenario? It can mathematically prove all those scenarios so you don't have to. And some of those you probably won't be able to. If you don't have kids, Netflix has chaos engineering, so you can randomly turn off things in your Heroku or your AWS. Chaos engineering works really well to figure out these weird problems. NASA's good about creating that, but for ourselves, if you don't push random buttons, that's a great way to actually automate that. Challenger was, to this day, still used in whistleblowing and ethical management. Nothing to do with software, just providing a safe environment where you see something wrong, you do about it. Like Google, what do they have to do? They literally have to walk out of their office like to protest this treatment of their employees. It's ridiculous. They should be able to whistleblow and get this guy not $90 million, right? And then Mars Climate Orbiter. End-to-end testing, they could have done even one test and see, all right, so if it goes to Mars, it actually went to Pluto, WTF. Like, they could have figured that out. They didn't. Code comments, everyone says code comments are bad, but even if it's crap code, at the time that you read it, you know what it does. It is the perfect time to say, all right, it's crap, here's what it does. Somebody later goes, okay, I'm never gonna read this, but this wonderful comment told me what it does. And then if you ever rise to a leadership position, being invested in quality engineering practices, if you believe in them. And again, I always tell developers, don't ask for forgiveness. They could have hacked this in. They already had a small crew managing these satellites to Mars because of budget cuts. So a lot of these people are doing 50 things, AKA they're doing 2 things. So had they basically just, it's just a quality unit test, and they upload it, they could have fixed it, right, without our permission. Ariane 5 try-catch. Seems simple. It would have saved $500 million with one try-catch. I think the rocket still would have gone off course. But anyway, it wouldn't have blown up as quickly. I'm still on the fence about the manual interview. I don't know enough about it, but I can now have a better appreciation why Elm, for example, forces you to do it. Property test, again, generate all those weird values. And again, copy pasta is fine. We all do it from Stack Overflow. As long as you test it, it's fine. So again, thanks for your time. I hope this was exciting as it was for me. And if you got any other questions, you can email me or hit me up on YouTube. I talk about a lot of other JavaScript programming topics. Thank you very much.